Methodologies for integrated STEM approaches. Currently, there is a concern about the reduced number of young people who are deciding to follow studies in science and technology. In response, STEM approaches are being proposed for helping citizens to acquire the needed scientific knowledge and competences that allows them to engage actively and responsibly in the society. The development of this scientific thinking implies not only the use of skills for generating, evaluating, and revising evidence and theories, but also the metacognitive processes to reflect on how knowledge is acquired. Integrated STEM proposals need to use some active and dynamic methodologies such as inquiry and engineering design. But what is it required for teaching by following these methodologies? On one hand, inquiry-based teaching should involve activities that include the analysis of scientific questions, the use and development of many process-related skills, the development of explanations and models using evidence, the extraction and the public presentation of conclusions from the results, and of course, the group work. On the other hand, engineering design process requires activities for the identification of a specific need or the improvement of an existing solution, the definition of factors that limit the solutions, including knowledge, materials, cost, time, and characteristics, and the use and development of many process-related skills, such as conduct background investigations, develop multiple possible solutions, creating, testing, evaluating, and redesigning a prototype, the group work, and the public presentation and discussion of the results. Then, inquiry teaching can be defined as a set of activities that help kids improve their reasoning ability and their ability to move from basic to more complex notions, learn to create their own strategies and solutions, exercise their deductive capacity, improve the relationship with the physical environment and the perception of spaces, shapes, parts, and the whole, practice the construction of their own learning, and learn to solve problems in real situations. In the case of the engineering design process, kids improve their systems thinking. They learn how to clarify needs, check existing solutions. They exercise creative problem solving, generating ideas and solutions with others, seeing engineering as a team sport. And they became aware of the difficulties of executing a perfect solution, and it is highly motivating for the development of an environmental awareness and a critical spirit. Kids also practice to make things better by designing, sketching, guessing, prototyping, and experimenting, and finally, they practice adaptability by testing, analyzing, rejecting, and changing in a physical and in a mental sense. Although research suggests that young children can follow inquiry methodology, some adjustments have to be made because inquiry is about questions, and kids have some difficulties to ask questions about something they have not seen, touched, or experienced. In the same way, engineering process needs to define problems or identify a demand that requires a practical solution, which is a bit complicated for young children. So for them, it is very important to notice, wonder, engage, and question, without forgetting the importance of giving them time to play in a rich science environment. As many of the emergent questions or problems may not be possible to investigate, children need teachers to focus observations and to define questions. After that, children can, with teacher support, follow the other stages. In conclusion, we have to create a science environment where kids can play, explore, discover, and question in order to help them to understand the world of which they are part of.